Hey, welcome back to Math with Patrick. Today is November 3rd, and we're solving problem 307 from the Daily Epsilon calendar. And the answer today should be 3 because that's today's date. So we have what looks like a trig equation here, some trigonometry. We need to figure out something about either theta or we need to find secant of theta because that's going to be equal to x. I know that secant of theta is the reciprocal trig function of cosine. So also if we find something about cosine of theta, we might learn something about x. So I think that's going to be my overall goal here, where I'm going to start with this equation that we're given and try to rewrite it in terms of cosine, because that will lead me closer to hopefully getting an answer today. So I'm just rewriting the equation here, sine to the power of 4, or rather sine of theta to the power of 4. This is just a little shorthand to say that we're raising it to the power of 4 later. Divided by 8 plus cosine of theta to the power of 4 should be equal to 1/9. And I think, so again, my overall goal is to rewrite everything in terms of cosine. Also, I don't really like the idea of having fractions on the left side. So maybe I'll multiply everything by 8 first. So I'll have an 8 cosine theta to the power of 4. And then I should multiply both sides by 8, so I get 8/9 over here. And then I can rewrite sine squared as 1 minus cosine squared. This comes from the Pythagorean identity in trigonometry, where essentially it comes from a right triangle. Cosine is going to be your x value, sine is going to be your y value. So squaring them and adding them together equals the hypotenuse of like a unit circle. And then you can rearrange the Pythagorean theorem to be able to replace sine squared with an expression in terms of cosine squared. Now this is sine to the power of 4, so it is like sine squared and then squared. And then here I'm going to replace that sine squared with 1 minus cosine squared of theta. Going to keep this 8 cosine to the 4th of theta, keep this 8/9 over here for now. And let's see if we can expand that square and collect up our like terms. So let's see, it's the first times the first, which is just 1, twice the product of these two, so minus 2 cosine squared theta, and then squaring the last term, plus cosine to the 4th theta. It looks like we're adding another 8 cosine to the 4th theta, so why not? Let's just do that right now. We'll do plus 9 altogether, still equal to 8/9. Oops, not just the number 9. 8 cosine to the power of 4 theta equals 8/9. Okay. And this is kind of looking similar to like solving a degree 4 polynomial, the way that you would solve a quadratic. And I'll show you what I mean. I'm going to subtract the 8/9 from both sides, and then rearrange the terms over here so I have what looks more like a polynomial in standard form. I'm going to move that 9 cosine to the 4th theta to the front, minus 2 cosine square theta in the middle, and then subtracting the 8/9 from both sides, I'll get plus 1/9 is equal to 0. And then if I do a little bit of substitution here, say cosine squared theta equals, let's just use t to substitute in because we haven't used that variable yet in this problem, then I can rewrite it as 9t squared minus 2t plus 1/9 equals 0. And I'm really hoping I can factor this and just solve it like a normal quadratic. So we could try splitting up this 9t squared as like 3t and 3t. We could split up this 1/9 as 1/3 and 1/3. Given that our middle term is negative, and the last term is positive, both of these signs should be negative signs if we can factor it like this. And then I notice if we do if we expand it all out, this gets us 1 minus t, and this gives us the other minus t. So this factoring actually works. And so we have 2 factors, and well, it's the same thing actually, so I could rewrite it with a square instead, kind of like that. And that shows me that the argument, or this little inside part of the square operator here, needs to be 0. So 3t minus 1/3 itself has to be 0 because there's no other number that squares to 0. Unless you're working with like dual numbers, but that's something silly. Solving for t, we could add 1/3 to both sides, and then we can divide by 3. So we know that t is 1/9, and let's see what that means back for that trigonometry. Okay, so we can kind of see here that t is 1/9, and then we can learn what this means for cosine. So cosine squared theta equals 1/9. Essentially, this means that cosine of theta must be equal to 1/3, or maybe cosine of theta is equal to -1/3, because once we square either of these values, we will get back to 1/9. And we did have a limitation here on x. X has to be positive. So I'm guessing we're going to find two solutions. And then, oh yeah, no, that makes sense. Okay, let's use this substitution here. Cosine of theta could be 1/3 or -1/3, and we'll bring that up here. Because I was able to get x in terms of cosine, now I can fill it in. Either x is 1 over positive 1/3, or x is equal to 1 over -1/3. The first option does give us the number 3, and that's our answer. And then the next option gives us a -3 as the result. And so since we have this condition here that x is positive, we can throw that solution out. Also, it wouldn't make sense for today to be November -3rd. That's a little silly. So this is it. Looks like we can solve our trig problem by converting it into a quadratic. And then doing all the algebra, we can figure out that x is 3 today. So I think we're all done. Thanks for watching, and I'll see you tomorrow.